morning, everybody. It's already lunchtime, but we have an exciting program for you before the break comes. We bring space to Estonia. We bring space to Latitude, and I'm really very pleased and honored to welcome you all in a very exciting 45 minutes on the topic of space technology, startups, innovation, and entrepreneurship. My name is Daniela Dobreva-Nielsen, and I hope I can find the button here. Oh, yes, here. And I have the pleasure to guide you today through this session. We are managing the program CASSINI Matchmaking on behalf of the European Commission, and as a start, I'm very pleased to welcome Thomas Johnson from the European Commission to introduce you to the CASSINI Matchmaking program, and then we take it from there. Thomas, the stage is yours.
Thanks so much, Daniela, and thank you to Tallinn for hosting us here. So CASSINI is a European initiative to boost our space industry in Europe. And yes, we do have a vibrant space industry, and not only the established space companies like Airbus and Thales and so on. We have a number of very exciting startup companies that are producing, new products and solutions for Europe's future space endeavors. And we have brought with us a number of companies from different countries today who will be pitching to you. I hope you'll find it interesting. I'll say a few words about what the European Commission is doing. So we are putting together an ambitious agenda where we have a €1 billion investment facility, which is being channeled to venture capital funds who want to invest in space-related startups. And the European Investment Fund here is our implementing partner. So investors who are interested should talk to them. We're also combining this with a variety of actions to make companies investment ready, such as the CASSINI Business Accelerator, which has just kicked off with 20 super exciting companies. And we run CASSINI Matchmaking in different cities, in different countries, at the various tech shows around Europe. We've already had 7 events. I think this is our 8th event. And we complement this with various challenges and competitions, such as the CASSINI hackathons. So we have a super exciting plan ahead for the coming years. And you've maybe heard about the plans to create a new constellation of satellites that will provide broadband connectivity, secure connectivity, everywhere, anywhere you are, in Europe, in Africa, even on the North Pole. So this is what we're building in the next few years. So a very special welcome to the startup companies who will be pitching here in a few minutes. And let's see, Daniela left the stage now. So should I make the transition to Jakob or to you?
I'm here. I'm here. So no, we have a very dynamic startup community. So
great. And if you want to know more, you can always visit the website cassini.eu, where you have all the information. You can also reach out to us in the European Commission. We're no further away than a telephone call, or you can reach out to our space agency in Prague. We have Stefan here in the room. And we're also working closely with ESA, the European Space Agency. So
yes, thank you very much, Thomas. Thank you very much. Applause for Thomas, please.
And now we'd like a representative from the Estonian Ministry of Economics to say a few words.
Yes, welcome to stage Sigrid Rajalo from Ministry of Economic Affairs and Communication of Estonia. Sigrid, the stage is yours. Applause for Sigrid, please.
Do I need this?
Yes.
So double microphones. Good morning, everyone. It's a pleasure to be here, and it's an absolute pleasure to welcome you all here in Estonia. For those of you who haven't been here before, I hope you make the best of our quite vibrant startup ecosystem. There's a lot happening right now, and I also have to mention that you are quite fortunate for the weather, because it's not usual for Estonia to have such good weather in the middle of May, so make the most of this as well. Well, on behalf of the state, of the Ministry of Economic Affairs and Communications, I'm really glad to see such great companies present here, waiting any time to get on with the pitching, because I think that it aligns very well with all the policy initiatives that we have in Estonia as well, and not only in Estonia actually, because space policy is part of, I'd say, deep tech policy, deep tech initiatives, and in Estonia we have realized that we need to step up, we need to take the game to higher levels in this sense that we need to support more deep tech developments, and space-based technologies is a really big part of it. So we have recently adopted a deep tech action plan, and we are looking forward to starting to collaborate with our Nordic partners to create this new Nordic Tech Valley, so stay tuned for more news to come in this area. And also space policy is very important for Estonia, because we just started drafting our very first space law, so stay tuned in that sense as well. And also, speaking of space technologies, and I know that some of you have in mind dual use as well, and dual use in today's world is, I think it's kind of like a hygiene factor already to start thinking about dual use technologies because of all the crises that have happened around us, unfortunately. So it's also a must, and I'm really happy that NATO has also realized this, and in Estonia we will be opening NATO Diana Innovation Accelerator, and these dual-use technologies that I'm quite sure many of you are thinking about, start thinking about Diana as well to use its possibilities and opportunities. And besides NATO Diana, there will be also a NATO Innovation Fund. So without further ado, there's lots happening around in Estonia and in this region, so pay attention and use all the possibilities that come on your way. But with further ado, I will stop here, because I'm quite sure that the main characters of today's pitching session are eager to step on stage. Thank you.
Thank you very much. Thank you, Sigrid. A pleasure to have Sigrid on stage, and indeed, very exciting developments in all the different European countries. What we bring with Cassini is the pan-European strength of the whole space-related ecosystem, and this is something that we would like to show you in the next half an hour. So we have brought together, as also Thomas mentioned, a group of very different startups covering different areas. We, within our space bubble, we use the terminology as, upstream, downstream, meaning technology that is used for bringing technology to space, and space technology that is helping solving solving problems on Earth using space data or signals. So you will see the pictures of all these exciting companies, which is a mixture of different technology. And then we're very also pleased to make further support for these companies. So if you have any additional questions, we have so many companies for this limited period of time, so we will have a quick pitches. But if you have questions, please address the companies directly, or just come to me afterwards or during the presentation. We will be here in the afternoon. And last but not least, before we start, I would like to invite you also at 1:30 to the Bold stage. There will be a discussion where Thomas Johnson will be participating. talking about deep tech, about how space contributes to the whole picture, what are the links. So this is also additional invitation to you if you are interested in space and deep tech. Don't miss this item. So we have our first startups at the sideline waiting to jump on stage, and he is a perfect example of being dynamic and arriving 1 minute before the presentation. So please, Magnus, join me on stage. Please applause for Magnus. He made it on time. The stage is yours.
Thank you, Daniela.
Here you are. Maybe you push.
All right, so I'm definitely part of this vibrant startup community that she's talking about. My name is Magnus Arving. I'm the CEO and co-founder of Intention. And at Intention, we're helping employees and anyone really operate robotics regardless of their skill level. And we're doing this by creating a platform for robotic asset management. But first, who are we and why should you guys care? 6 years ago, a bunch of engineering students met at a top scientific university in Norway. We were united in the vision of creating a new way of how to interact with machines. So we created this device, a sensor-based glove that we use to fly drones, control robot arms, control music, and even connect to VR. Then, 3 years ago, we met this guy, Dr. Pascal Lee, planetary scientist at NASA Ames Research Center and the chairman of the NASA Hot and Mars project. He immediately saw the potential of our technology, and we've spent the last 3 years validating, researching, developing, and integrating our technology into analog spacesuits together with an industry collaboration partner. And I'm proud to say that that partner is now our largest customer. Along the way, we have started building what we call Intention components. That is essentially blocks of reusable IP, such as this one, where we... Oh. Does it play? Nah, okay. Video of astronaut playing with a drone using his hand, one Intention component. But long story short, we're now targeting the global robotics market as our technology has more applications than just space. There are several problems here in the face of human-machine and human-robot interaction that we believe that we can address. And we have a unique solution that lets the user, the employee or the operator, use their own body as their input method to control and operate machines. We have built new ways of controlling robotic assets through the use of XR. For example, path planning in virtual environments by using just your hands to create simple paths for a drone in a completely virtual environment, and use your hands to scale the model and get access to viewpoints that you would never have standing on the oil rig. That's another component created. What is unique about our solution is that we are connecting the devices, the sensor gloves, the XR headsets, with the virtual environments, digital twins, BIM models, or real-life sensor data with the physical robotic asset, the robot arm, the drone, and the rover. That's what our platform does. And there's tons of ways to monetize this. The opportunities now, we're raising $1.3 million in our seed round. We already have a contract with a major American space customer. We have received over $500,000 in grants for platform components. We got a strong team, great traction, already 550K soft committed in this round, and we're now looking for potential customers and elite investors to take it home. Thank you.
Perfect. Please, yes, thank you very much, Magnus. Well done. It was worth it being on time. So very much appreciated. So let me have a look. Magnus had a bit of more to show. But then we come to the next startup, and I'm very pleased to introduce a startup that is coming with the 3D printing technology, and something that I think we all know by now that can contribute a lot to a lot of technology. So please welcome Jakob from Orbital Matter. You are, and you have 3 minutes.
At Orbital Matter, we are developing cheaper, simpler, and greener way of manufacturing directly in microgravity for satellite manufacturers and prime contractors. thanks to our 3D printing technology that works directly in exposed space. Currently, all the space equipment is made on Earth, which creates multiple limitations. First of all, it has to survive the rocket trip to space. Its maximum size is limited by the cargo space of the rocket. And finally, its operational complexity is high because satellites have to use a deployable mechanism to extend their volume, or in case of large space infrastructure, modules has to be assembled together to form larger structure. We're flipping the process, and we are transporting only raw materials and 3D printers to space, so we can manufacture much lighter and larger structures directly in microgravity, cheaper and faster than anyone else. Our go-to-market strategy assumes 3 steps. So we're starting with pilot contracts and contracts with space agencies. Then from 2026, we plan to start selling 3D printing deployable modules for satellite manufacturers. And finally, from 2030, we'll start operating our own 3D printing spacecraft that will provide construction services for multi-billion contracts directly in Earth orbit for projects like commercial space stations, lunar infrastructure, or space-based solar power. My name is Jakub. I'm CEO and co-founder of Orbital Matter. I have 10 years of experience as entrepreneur with already 2 successful exits. And my co-founder, CTO, Robert, has years of experience in designing, prototyping, and building 3D printers, with his most recent experience at Formlabs, a 3D printing unicorn. We already demonstrated our 3D printing technology in simulated space conditions and applied for a patent for it. From commercial side, we have 7 letters of intent, including 1 from Airbus, and we'll discussing the start of collaboration with Thales Alenia Space this autumn. Currently, we're focusing on applying for European Space Agency contracts together with partners, and with the final goal to demonstrate our technology in space and make sure it meets the needs of the market. We have signed a term sheet with the lead investor recently, and we're raising 600K round with 150K tickets still available. Thank you very much.
Thank you very much, Jakub. Thank you. So we came a bit further in our space journey, and actually, what is space without launching a rocket? So many of you may have this association of space related to launchers. And as you've maybe followed, there is a lot of monopoly currently in the global market regarding launchers, and that's why we are very, very pleased to support also smaller startups and smaller companies that are coming with new technology for small launchers or also exploring technology. So I have a pleasure to have Gerardo here. Please welcome High Impulse.
Thank you, Daniela, and thanks for giving us the great opportunity to present you today High Impulse. My name is Gerardo Schirillo. I'm the fundraising manager of High Impulse, which was founded in 2018 in Germany, and with the mission to make access to space. It's okay, can you? Oh, sorry. So it was founded in 2018 in Germany with the mission to make access to space simpler, cheaper, greener, and address the issue of the launch capacity bottleneck that we currently have in Europe, where only 3% of the launches take place today in Europe versus an estimated demand of 25%. How we want to do that? With our small launcher called SL1, which is a 3-stage rocket capable of sending 500 kilograms to low Earth orbit, and this is powered by our own proprietary hybrid propulsion technology, which uses paraffin, so candle wax, as fuel, and this has the unique characteristic of not being explosive, so there is no catastrophic failure. This greatly simplified the manufacturing, the assembly, and the ground procedures. This ultimately results in lower costs, lower lead manufacturing times, and therefore also the ability to launch more frequently or, let's say, have more launch capacity. Here you see a more detailed view of the launchers, which is not only designed for being low cost, but also for being more sustainable. So we plan to reuse the most complex and expensive parts, like the turbo pumps. Where are we today? Our technology is mature to fly. In fact, we will fly our first suborbital launch this year. We have 100 million euro order book from 15 plus customers worldwide, and we raised 22 million euros so far, and we are currently raising 20 million euro Series A fund. So who is making this happening? Here's the team. We are about 50 people from 15 plus nationalities, and on the left you see the founding team who has been working more than 10 years together, and they have the unique feature that they are the only founding team in the world who has already successfully achieved a rocket launch. This was in 2016. As a student group, they established the world record altitude for a student rocket. So we are confident that we can make it, and we look forward to your support from the investment community, customers, and happy to take your questions and feedback. Thank you.
Thank you very much. Thank you very much. So we came to, we talked about launchers. We started with technology. Now we continue with technology because in order to be able to have disruptive innovation and also through startups, we need different components in the value chain, and we need different technology to address the different needs. And now we have a pleasure to welcome DB Space talking about electric pulps.
So good morning, everyone. My name is Dario Bruna, founder and CEO of DB Space. DB Space is an Italian startup. We are in the upstream segment of the space economy, and we are developing the next generation of electric pumps, and we do this for all the space manufacturers. They need a cost-effective and highly reusable pump for their propulsion system. So we started the company in 2021, and we have a strong roots in propulsion. And so what we start from is looking at the real challenge. And real challenge in rocket propulsion is turbopumps. Turbopumps development is complex, it's very expensive. Indeed, the turbopumps are the most expensive part of the rocket engine. And you need turbopumps to have high performance in any kind of liquid or hybrid propulsion system. And this is especially related to the turbine, which is like the difficult part of the turbopump. And on top of that, there is all the new space economy that require really short lead time and reusability. So there are all these challenges, and so we come up with a solution. And for us, the solution is turbopump electrification. And the time to do is now, because now we have all the technology, power electronics, energy system, batteries to do this. And with our proprietary technology, we can reduce complexity, we can maximize usability, we reduce the cost and development time, and to offer even more value to our customer, we offer hardware as a service, which means we can reduce their capex and we reduce their risk in technology development. So currently, we're looking at the scalable technology that can be applied to many products. We're focusing on small engine, and we are so in the bottom left of this arrow, where with our technology demonstrator and first line of product, we can cover kick stages, small spacecraft, large spacecraft, nano micro launcher, and planet exploration vehicles. And we are at the prototype verification phase. We have our in-house capability for testing, and right now we are focusing on kick stages and micro-launch products. And we started the company in 2021 with a strong experience in aerospace industry. We come up with different also background, and the team is growing as we are hiring 2 people in the last 3 months. We have in the pipeline to get another person. So far, we raised $500,000 through VC, Business Angel, and family and friends. And we are looking now for a larger seed round of about $3 million. And we're very pleased to be here as we want to also meet potential customer, potential partners for early adopter, and also suppliers for our supply chain. So if you want to talk about rocket science, rocket technology, please, let's have a chat. Thank you very much for your attention.
Thank you very much, Dario. Thank you. So when we started talking about space, I mentioned that we have the two different areas of using space technology to reach space and using space technology for needs and solving problems on Earth. So the next company is talking about problems that are related to something that we are very interested in currently. It's about energy, it's about becoming competitive, it's about using new technologies, and I'm very pleased to welcome on stage Rexplorer.
Thank you. Hello, I'm Henrik, the CEO and co-founder of Rexplorer. And yes, as mentioned, we are working downstream, so we are making our technology work with the help of space here underground. And we are automating rooftop solar energy. Currently, solar energy is the fastest growing renewable energy technology, growing worldwide, and already in 2.5 years, it will double the power capacity it has at the moment. And 40% of this power is being produced on the top of buildings, on top of roofs. And this is our sector. So making all these installations work, it needs scalable planning tools. And this is our solution. We combine infrastructure data with Earth observation data to make automatic modeling of any type of building roof and place solar modules on top of it, calculate the power production, investment cost, CO2 emissions, all the necessary parameters. Uniqueness of this is that we have the roof measurements that makes it possible to project this installation without visiting the site at all. And we have a secondary segment as well. Because of automating, we don't have to do only one project, one engineer method of drawing a layout. So we can do 1,000, we can do 10,000. So we are looking to utilize this software to make solar energy modelings for entire cities. Our main customer at the moment is energy companies, so this is B2B, and we improve the sales and the project management, as I explained. And for cities, for the PropTech sector, we are looking to be a large-scale database for energy and climate planning. We are currently a small team led by me with background in environmental data management, and my co-founder Ilya with background in satellite monitoring and product development. We are early stage, and we are planning this year a seed round, looking for a lead investor for that. And the reason for it is to scale up to new, bigger markets. Our target markets at the moment are Germany, Japan, Canada, and different cities across the EU. So if you find this sector interesting fit for you, please find me after the pitch.
Henrik, thank you very much. Thank you. Yes, so we came back to Earth, but as you could hear from Henrik, what they do is actually something using space data and signals. And we have our next startup, welcome on stage, 10 lines that are also facilitating data. Here you are.
Thank you. Hello, my name is Tarmo Prints. I'm the CEO and co-founder of 10 Lines. At 10 Lines, we are developing autonomous robots and software for the industry of payment marking. The problem of payment marking today is that it is almost entirely manual work. About 70% of the time that is done on the work field is spent on measuring and pre-marking. This means that teams of 3, sometimes 4 people are using long measuring tapes, chalk lines, spray cans to mark down every line on the asphalt before the actual lines are painted with this manual machine that you can see on the photo. I was in the striping industry for 12 years, a little bit more even. And as an owner of a striping company that today stripes the most parking lots in Estonia, I was trying to find better ways of doing the business to improve productivity, profitability. And I was going through the industry biggest players. and there was no automation or digitalization that would actually improve the whole process. Our solution to this problem is an autonomous robot. With our robot, we don't require any pre-marking. It gets the job done 7 times faster, and while doing the work, it reduces CO2 emissions about 2 tons a year. With 10 lines robot, a job that used to take 3 days for 3 people takes only 1 day with just 1 robot and operator. So the improvement in productivity is significant. The other thing it helps is that our clients are striping and paving companies, and they have been telling us that it is really difficult to grow and scale the business. With 10 lines robots, instead of having 3 or 4 teams, which is already hard to handle, they could easily have 20 teams because all the robots can do the same job. We rent the robots out for the average cost of a crew member, which is about 4,000 euros a month. We have a strong team of engineers. My co-founder Janna and I, we decided to start this company because Janna has a very good background in AI, machine learning, robotics, and I have a strong background in the striping industry, but also sales here in Europe and US. At the moment, we have a robot in the hands of a client here in Estonia that is using the robot to provide service to their customers. And in the second half of the year, we will take our robots to Florida. We already have a list of customers waiting for the robots there. But to get the robot to the scalable model, we have the robot doing a great job and accuracy, but to be able to operate tens and hundreds of robots, we need to do a little more work. So we are raising an investment round of 500,000 up to 1 million euros. And currently we have Terra Ventures already joined the round and they lead it. I hope you join us and let's stripe the future smart cities together. Thank you.
Thank you very much. Thank you very much. So we continue with another local company, and I'm very pleased to say that we had a very good contribution from a local ecosystem to CASSINI matchmaking and to the European Commission program, and also to this performance. So the next to come is Jan from Loud Code Photonics. Please applause for Jan.
Hello, my name is Jan. I'm a co-founder and product owner of Latitude Photonics. The dream of space exploration has been ongoing for more than 50 years. And while we've launched awesome rockets into space, we've sent satellites into orbits, we've even went to the moon. Once we get to the actually the space and other planets, we will need to do something there. And putting a person on a moon and on other planets is going to be difficult in the long run anyway. Robotics can provide a solution to that. However, for that they need to be autonomous. They need to be able to work independently without a human operator. Today, the autonomy of robots that are working even here on Earth is insufficient. They will need good quality data to make their day-to-day autonomous decisions, but the conventional sensors, such as color cameras, are not enough to do that. They need ranging or distance information to objects in their field of view to complete tasks such as understanding what's in front of them or where they are. There are some competitor solutions out there, but they are either prohibitively overpriced or lacking in performance. In Lightcode, we are building a 3D camera. We are used to the notion that you will need a lot of pixels in order to form an image. The phone cameras in our pockets have millions of pixels. If it would be that easy to complete a 3D image or to form a 3D image with that types of sensors, we would do it. However, there are technical difficulties that prohibits us from from building those types of sensors. So Lightcode has a unique solution that allows to form an image using only one single pixel without any mechanical components. In addition, this is software controllable, which makes it easier to optimize for detail where you need detail and data bandwidth when you don't need the detail. In addition, it allows for easy integration with already existing technologies such as color cameras to make a really comprehensive sensor suite. Our journey will begin by solving the questions, or the autonomy question here on Earth. We will start out by automating or increasing the autonomy of applications in simpler environments and and we will progress to more complex applications and environments. By doing that, by proving that the autonomy is sufficient here on Earth, we are demonstrating that autonomy can work on other planets as well. Simultaneously, we have a 200,000 development agreement with the European Space Agency to develop a space-grade camera. And this will pave the way for autonomy in space. Join our 7.8 million euro seed round in 2024. Thank you.
Thank you very much. Thank you very much. So our startups are so well prepared. We are so pleased to see that they are keeping the time. We actually didn't count on that all the time. But if you have any questions or comments, I think they're all around. Please address them directly or come to me later on. So we continue with unfortunately, the single lady on stage from among the startups. Eleonora, please join us. CMW. You are.
Thank you. Hello, I'm Eleonora. I'm board member and CEO of SMW Group. We are a manufacturing company. Just a second. Oh, no, I'm sorry. Okay. So you can see I'm single lady here. Well, we are a manufacturing company. Forging and 3D printing metal components are key advantages that we can guarantee that we'll manufacture components which are at least 30% lighter than other components currently existing in any end vehicles, whether it's satellites, antennas, or any other basically components you'd need. By this, we can increase the efficiency, reduce emissions, and also decrease the operational costs of the end clients. How do we do this? By working with magnesium. Magnesium is structural material. We can use different alloys, thus also substituting such metals as steel, titanium, aluminum in different occasions. Basically, we receive the technical assignment and then work on it. Also, we have the capacity for the design optimization, which ensures that we can maximize the weight as much as possible. As per the customers, whatever customer needs, we can manufacture thus we can target different markets. Currently, we're more focusing on satellite and antenna manufacturers, as we've signed also now the agreement with Thales Group for 16 different component manufacturing, and one of the technical assignments is these antenna boxes. This is our team. We are younger and more senior people, different nationalities, and our founder of the company is also has been also the key shareholder of Solikamsk Magnesium Works, which is the oldest magnesium smelter in the world, and from there most of the metallurgical capacity comes from. Currently, we received the grants over 1 million euros from European Regional Development Fund. Also, we have 2 contracts with European Space Agency, and finally, we're also signing first series agreements. So far, we've been only in the prototyping stage, and our financial goal is increase annual revenues by 30% annually. Currently, we're seeking investment of 800,000 euros, and yeah, thank you.
Thank you very much, Eleonora. So actually, we have 2 to go, and I have the pleasure to invite another Estonian company that is working on cybersecurity. Please applause for Scudo. Here you are.
Thank you very much. My name is Stefano Alberico. I'm the CEO. The other way. Sorry. I'm the CEO and founder of Scudo, and we work with cybersecurity applied to space and drone communication, so we protect data communication. And in space is a little bit of a Far West, so everyone does a bit his own cooking recipe, and mostly due to the fact also that there is a lack of, let's say, standards for space communication that support modern technology. let's say there is no standard supporting authentication based on digital certificate, which is widely used on Earth, so it's very difficult to identify the asset. Another important aspect for us is working with the hardware-based encryption authentication rather than software. Software can be, prone to weaknesses and bug. And the most important also is to be fully transparent. So many of those technology you find on the market are basically black box and you don't know anything about it. So our idea is simply to bring basically a digital certificate on every digital asset in space and on the ground, and use an encryption chip, so-called hardware security module, which provide cryptographic functionality on all those assets. And then the advantage in here, for example, one very simple to understand is that if you send a command to a satellite and you want to switch on a thruster and change the orbit, you need to be sure that that command is sent from the authorized person. So with a digital certificate, which is something, again, on Earth we do all the time, we're used to, then it would be extremely, let's say, secure to do something like that. And then you use encryption. Many people usually talk about encryption only, but the real problem, the challenge, especially in space, is really to authenticate before starting to run this kind of encryption. And what we have done is we build an encryption chip, so it provides all the cryptographic functionality that are needed in all applications. We develop also software on top of it, otherwise the chip would be useless. So we work with the space data protocol, also with drone protocol. And then the very important bits is, of course, we are based in Europe, so this is cybersecurity made in Europe, dual use, by the way. And the important is completely verifiable. If today you buy from the market an encryption chip, is a black box, blind trust, you don't know if there is any, let's say, backdoor in there, while our technology could be completely verified by third party. We have a very skilled team, so we are capable of doing hardware implementation, software implementation, and of course we are based here in Tallinn. And we are basically financially self-sufficient, so we work mostly with the European Space Agency, and we are looking for a seed round, or let's say around $500,000, mostly for growing up and strengthen the team, but we are very much interested in find also partners to cooperate together. Thank you very much, and catch me if you need any more information. Thank you.
Thank you. So time runs fast, but we will not leave you with a bit behind without telling you a little bit about a new type of small satellite platforms. And I'm very pleased to welcome on stage Reflex Space. Alex, the stage is yours. Last but not least.
Thank you. Hi everyone, my name is Alex. I'm co-founder and CEO of Reflex Aerospace. My background is in aerospace engineering. I was an officer in the German military. My co-founder Walter has a commercial background in CubeSat manufacturing. And something that we noticed when we met is that there's a need for a new player in the commercial but also dual use domain for small satellites in Europe. So why is this the case? I mean, we all know the numbers, the high revenues that are expected, the demand of 100,000 satellites in the next decade. This is not a problem. The problem that needs to be addressed is the one major bottleneck in the satellite industry, which is platform manufacturing. Let me explain to you why that's the case. If we look at a very typical product that we all have in our pockets, probably a smartphone, you will notice that this very thing has been in your possession for maybe 2 or 3 years, not more than that. Why? Because then you replace it. Usually not because it breaks, but because it becomes obsolete. Every product in sensor electronics, in consumer electronics becomes obsolete after a certain amount of time. And then you need to replace it because it's useless. You can't compete with it. In the term of technology, especially in a government use case, you need to replace it to become and stay competitive against your adversaries. In a commercial setting, you need to replace technology to keep the competitive edge against other companies. So, but the thing we're seeing in the satellite industry is that a typical project, for example, an Earth observation here, satellite, stays in orbit for a time in which all the other technologies have passed through 5 or 6 innovation cycles if we do the comparison with the smartphone. So does this make sense? No, of course not, because the technology that we're flying on board of the satellite, it's the same circuits, it's the same electronics, it's exactly the same types of technology building blocks, but they get stuck in space, and due to the physical position of space, it's impossible to replace whatever you've sent up there. Yeah? So this has been a kind of unchallenged paradigm in the space industry, that we launched things and leave them up there in space for 15 years. And after a few years, they are already hopelessly outdated and obsolete. So Reflex Aerospace wants to address this one barrier to bringing up the innovation in the space domain to the same cycles we're seeing on Earth. And that's speeding up the manufacturing of satellite buses and also changing the operating system. That is to say, not to operate them up there for 7 years or 10 years or 15 years, but rapidly replacing satellites, responsively reacting to every iteration of technology that our customers, which provide the payload, are doing. And in order to do that, we need to dramatically reduce the time that is needed to build a satellite from the typical 3 to 4 years to below 9 months. We do this using different approaches, combining novel engineering techniques that we've seen in the automotive industry, in the sensor electronics industry, in the software industry even, and starting with a blank slate as a new manufacturing company to bring up the speed of innovation in the world of satellite platforms. So the traction of the company so far is we've built a team of 35 people in Munich and Berlin. I have a customer for our first satellite, which is going to fly next year. We've raised a total of 11 million from institutional investors in Germany, private investors, also some family offices in Europe with industry background, and are now raising additional 6 million euros in this seed extension to verticalize our further technology development. And something I also like to mention in the case of EU events is that we did one of the studies for the IRIS constellation a year ago, the new space contribution to that. So we're very, very hopeful to see that Europe will also take on the responsibility and bring new space innovation into the government use case that we'll be seeing with IRIS Squares and similar programs. Yeah? So we are glad to exchange ideas with anyone here, and yeah, looking forward to any question and follow-ups.
Thank you very much. I would like to thank all the startups and, of course, to you for your interest and attention to space. Space is everywhere. Space is in places where we don't even suspect it to be found. And this is something that we really foster, and we are very pleased to be able to share this 45 minutes with you. Thank you very much for your interest. Please approach us. As I said, 1:25 on the boat stage. You can see Thomas. Thank you very much to the European Commission for this possibility to support space startups. And let's try to continue innovating and fostering space technology. Thank you very much.